Division of rational numbers. We'll start off again by looking at a whole number divided by a fraction. Remember that 6 divided by 3 could be interpreted as how many 3's are inside of a 6? Well then 3 divided by 1/2 can be interpreted the same way. How many 1/2's are in 3? I've got 3 circles on the screen. I've cut each one into halves so that I can count just how many halves we have. How many halves we have. That's fun. Anyways, there's 2 halves in the first circle. There's 2 halves in the second circle, so now we're at 4. And then there's 2 more in the third circle. So there's a total of 6 1/2 sizes inside of the total of 3 circles. So we're counting how many halves are inside of 3. There are 6. We could use a number line to represent this as well. I've got 0 to 3 on a number line, and I've cut 1/2 marks so that we can count how many halves there are. From 0, I would need to go 1, 2, 3, 4, 5, 6 steps to make it to 3. So again, there are 6 1/2 lengths inside of the length 3. What about if we have a fraction divided by a unit fraction, like 3/4 divided by 1/8? We can still interpret this the same way. How many 1/8 are inside of 3/4? Well, we start with 3/4, and then we cut on the same circle 1/8. And then we just need to count how many of the 1/8 there are. Notice that the 1/8 are marked in red. I just need to count how many we have. There are 6. So if I did 3/4 divided by 1/8, I can see that my answer would be 6, because there are 6 of the 1/8 that fit in 3/4. Now remember that we have defined division to be the inverse of multiplication, which means I should be able to multiply 6 and 1/8 to get 3/4. So let's check our work. 6 times 1/8. 6 is a whole number. We'll turn it into a fraction. We get 6 over 8. But that can be simplified because 6 is 2 times 3, and 8 is 2 times 4. The 2's divide off, and we are back at 3/4, right where we started. We can solve this same problem on a number line instead of using a circle, simply by representing 3/4 on the number line. So maybe draw an arrow that points from 0 up to 3/4. And then look at how many of the 1/8 lengths would fit. So 1/8 goes from 0 to this first mark. So I could have 1, 2, 3, 4, 5, 6. So we have 6 1/8 lengths that fit into the length of 3/4. So again, we have the answer to be 6. Now if we compare this to the fractions that are written out, 3/4 divided by 1/8, we might think to ourselves, is there a pattern here like how the multiplication worked? Well, if I tried to divide across the top, divide 3 divided by 1, I would get a numerator of 3. 4 divided by 8, that would actually give me a fraction. 4 divided by 8. If I took the number 4 and I cut it into 8 pieces, I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces. This would have to be 2, this would have to be 1, 3. So 4 divided by 8 would actually be 1/2. And that's like saying 3 divided by 1/2, which we know we can turn 3 into a fraction. So that didn't help much, just dividing across the top, because we ended up with a whole number divided by a fraction yet again. Now, 3 divided by 1/2, we can do a visual to find that out. But if we wanted to find a relationship that we could quickly calculate this without having to draw a picture, we just realized that's not it. Don't divide just straight across the top. Although technically you can get the right answer, that's not what we want to do here. Maybe having a common denominator would help. So 3/4 needs a factor of 8 multiplied to top and bottom. And 1/8 would need a factor of 4 multiplied to top and bottom. Then we can try dividing across the top. We have 3 times 8 divided by 4. So that would look like 24 divided by 4 on top. And then on bottom, we'd have 4 times 8, which is 32, divided by 8 times 4, which is 32. Now this time, because we went through the process of finding a common denominator, when we divide our denominators, we're not getting another fraction. 32 divided by 32, that's equal to 1. But then on the numerator, 24 divided by 4, that's equal to 6. So we get our 6. So we could do this process of multiplying to find a common denominator and then divide across the top, divide across the bottom. Or maybe something that you're noticing here is that the denominator divided off to be 1. So finding the common denominator essentially turned our denominator into a 1. But what it did to the numerator is what's really interesting. The 8 from the 1/8 multiplied to the 3 from the 3/4. The 4 from the 3/4 multiplied to the 1 from the 1/8. And since the denominator ended up being 1, it really didn't matter what was happening on bottom. So simply by looking for a common denominator, we found that we could instead do 3 times 8 divided by 4 times 1, or 24 divided by 4, which gave us 6. You might have heard of this before, where you take a fraction and you flip it and multiply. And that's actually happening here as well. 3/4 divided by 1/8, giving us the same answer as if we did 3/4 times 8 over 1. 3 times 8 is the 24. 4 times 1 is 4. 24 over 4. That's the same thing as 24 divided by 4. We get 6. So if you've ever wondered why A over B divided by C over D equals A over B times D over C, the whole flip and multiply, well, now you know. It comes from an idea of trying to obtain a common denominator and then dividing across the top, dividing across the bottom, and noticing the pattern that happens. Now let's look at a fraction divided by a fraction, where we're not looking at a unit fraction as our divisor. 7/8 divided by 3/4, we can interpret that as how many 3/4 are inside of 7/8. To visualize this, we can take a visual representation for the number like 3/4, and we can try to picture how that would fit into 7/8. So if we think about a circle that's been cut into 8 pieces, where we're considering 7 of those eighths, we might think the 3/4 will definitely fit inside of there, but it's not going to fill up the 7/8 completely. In fact, the easier way to see this would be to draw eighths onto our 3/4 circle. And we can see that if we were to consider 7/8, 3/4 is small enough to fit inside of 7/8, but it doesn't fill it up completely. So if we look at this piece, we've got this extra part that is the 7/8 that's not represented by 3/4. So let's try the number line model instead. The visual model is a little difficult to try and visualize how many times 3/4 is fitting into that fraction 7/8, and the number line can help us a great deal here. I've got 7/8 written on the number line with this gold arrow, and I want to know how many times 3/4 will fit into that gold arrow. So I've got 3/4 represented with this orange arrow, and to make things easier, I'm going to copy that arrow up to the top number line. Now we can see here very clearly that 3/4 does not fit completely. There's extra space there, so there's this extra part that the 3/4 isn't reaching. And if I tried to draw another 3/4 arrow, it would go well beyond 7/8. So we can fit it in once completely, but then there's a portion that's left over, and we need to figure out how much that portion is. And if we copy that portion down to our 3/4 number line, we can see that it would require 6 of those tiny portions to get to 3/4, which means that one of those little arrows to fill in that last gap is considered 1/6 of 3/4. So we have to be careful with division by fractions in this case, because interpreting the visual can get a little bit confusing. Remember, we're asking how many 3/4 are in 7/8, or how many orange fit inside of the gold. Well, we had one orange arrow, but then we needed to take an orange arrow and cut it into 6 pieces so that we could fill in that last portion. So it would be 1 1/6. We could represent that as a improper fraction, as 7/6 if we wanted to. So we could draw 7 little arrows to represent the 3/4, and then the last one. So we could say that there's 7/6 3/4. That feels really crazy, but the mixed number makes it a lot easier to represent. So let's go back to the orange arrows here. We were able to fit 3/4 into 7/8 once, and then 1/6 of a time. So 1 1/6. And if we wanted to double check our work, we could remember that division is the inverse of multiplication, which means if 7/8 divided by 3/4 is, let's use the improper fraction here, is 7/6, then I should be able to multiply the quotient and the divisor. So 3/4 times 7/6, that should give me 7/8 if we found the right number here. Now 3 times 7 is 21, 4 times 6 is 24. 24 doesn't look like 7/8, but it could be an equivalent fraction, so let's reduce it. 21, 3 times 7. 24 is actually 2 times 2 times 2 times 3. So we can reduce the common factor of 3. We're left with 7 over 2 times 2 times 2, which is 8. So yeah, it was an equivalent fraction. We definitely found the right number of times that 3/4 fit into 7/8.